chance to get back and do another little video. These are the question 17s from the practice papers. So the first one we've got here, it says a circular garden bed, but when you look at the equation you can see it's not a circle, but that's really irrelevant. A garden bed has a boundary which is made of 6 minus x squared, the x-axis and the y-axis with all measurements in metres. That's a little bit misleading because there's two ways I could draw it, but we'll go with the intended one. The wording in your exam will be clear, it won't be ambiguous like that. So 6 minus x squared, upside down parabola, passing through 6, because it's been translated 6 units up. But because they said they want it between the x-axis and the y-axis in the curve, I guess there are two sides, but we only need to do one of them for this one. Usually it would say just the area between the curve and the x-axis, which would have been both sides, the unshaded and the shaded there. But for this one, when I look at the answers, it looks like they just want the shaded one. Obviously I need to know where to integrate up to, but this is a calculator question, so you can either go ahead and do the maths to figure out that this is at root 6 where it's intersecting, just using your difference of two squares, or of course you can just use your calculator to find that point. And then really all these questions is a very simple integral. So the area of the garden bed is just going to be from 0 to root 6, and the equation of course is 6 minus x squared dx, and then we're going to write using GDC. And that's going to spit out an area for me, and if I look, we could do the calculations, but I'll try and keep these fairly quick, and you can check it on your calculator. It's 1.6 root 6, which is some sort of number, but we're interested in the cost. It said that bed is excavated to a depth of 0.4 metres and the cost of excavation is $95 per cubic metre. So my cost is going to be $95 times the volume. The volume is 0.4 metres deep, and then I'm multiplying by 1.6 root 6. And again, you use your calculator, and it's going to spit out the answer of 372.68. But we check and see that it says to the nearest dollar, so approximately $373. And that's all we have to do. So again, the wording's a little bit funny in this one. That's what happens when we use AI to generate them. Don't panic too much about that. Do the working and it's pretty straightforward. This one here, I don't think I'll work through all of it. You're unlikely to get a description that says 3 identical regular dodecagonal coins. That's a little bit strange. 12-sided coins placed exactly side by side on a sheet of paper. If you go to the past papers, you'll see this is referring to when we had 50-cent pieces covering a $5 note, or I think there was another example with the Cook Islands. If you were to get this in an exam, it would contain the picture, which would make it a lot easier. If you want me to come back and do one of these, let me know and I'll find those old papers and do it. But for now, I think we'll just say I'm not going to do that one here. But it's just a matter of once you get, I guess I could show you the basic premise of it. If it's a 12-sided coin, I'm not going to try and draw one accurately here, then the central angle, 360 divided by 12, would be 30 degrees. And so I'm going to call this little bit coming out to the coin. So in this case, I've got the coin oriented on the note like that. So you can see there's the coin, and the other 12 sides are all sort of going around like that. And then you've got the other coins going off to the side. This one said how many were there? 3, so there would have been probably another 12-sided coin there and actually another 12-sided coin there. It doesn't really matter. What they've asked us there is to find the rectangle has a height equal to the distance between the two opposite sides of one coin. So yeah, it's the orientation that's important. This one, the orientation is that the flat sides are touching the top and the bottom, because the height is equal to the distance between two opposite sides rather than points. It could have been rotated so that they were meeting at a point at the top and bottom, like that. and that would just change the way you do the working a little bit. You'll see it in the other examples from the past papers. But from here, you go ahead and you find the area of one triangle, which is a half AB, which is x squared in this case. Sine 30, sine of 30 itself is a half, so this is just x squared over 4. So then the area of a coin would be 12 times x squared over 4, which would be 3x squared. And then you can do 3 coins. The area of 3 coins would be 3 times 3x squared, 9x squared. And then you could also figure out, I've got to figure out the height of this note. So I could then go away and find the area. And that's the tricky bit with this one. I've just got my triangle here, and I'd have to break it in half. So this would be 15 degrees, that's an x. And now you can go ahead and to find this height here, you can go cosine of 15 equals adjacent side h divided by the hypotenuse. So x cos 15 equals h. So when you now got the side there, that would be 2h. So you would make it 2x cos 15. And then you just find the ratio. I'm going to leave that one there. That gets a bit fiddly. And I think it's better if you see the diagram. You would definitely have the diagram in the exam. We wouldn't expect you to be able to draw that one. It just gets a little bit too messy, as you can see by my attempt there. Now this one here, a radar station is 10 kilometres northwest of a ship. Nice if you can say let R equal the radar station. And S0 equal ship's starting point. So a radar station is 10 kilometres northwest of a ship. So I'm going to have to draw my ship here, have my reference for north, and then 10 kilometres to the northwest. So that's going to be 10 kilometres, like 1 kilometre, and northwest, so that's 45 degrees around. And the ship travels due west. So the distance the ship travels finish reading the question. Travels due west at 16 kilometres an hour for 45 minutes. So the distance, of course, is speed times time. So that's 16. That was in hours. So my 45 minutes, I've got to make 3/4 of an hour. It's travelled 12 kilometres. Given that it's travelling directly west, and this 10 kilometres, which is a bit illegible there, I'm going to just draw that back in. Oh, doesn't that look nicer? 10 kilometres. That's going off at an angle. The 12 kilometres is definitely going to be longer than the 10. I've exaggerated a little bit there. I don't need to exaggerate. That's still good enough. But I know that it's going to have gone a little bit past, further west than the 10 kilometres did. So that seems about right. A triangular search region is formed using the radar station, the ship's starting point, and the ship's final point. So this was S0. I'm going to let SF be the ship's final point. And now it's just an area question. And the area, of course, is a half AB sine C, so that's a half by 10 by 12 sine 45. This is actually on the calculator paper, but that would be very reasonable on a non-calculator paper. And we're going to get 60 and then the sine of 45 root 2 over 2, or 30 root 2. We have the units for this. These are in kilometres. So it'll be square kilometres for an area. And we're done. All right, next one, a block of land bounded by 2 straight fence lines of lengths 85 and 120. The included angle between the fence lines is 62 degrees. You can draw this one however you like. I'm going to pretend that's 62 degrees. This one is 85 metres. This one's my 120 metres. It's not to scale, but that's okay. The land is sold at 155, so bounded by 2 straight lengths of fence line. And interesting, it didn't really say where the rest of the land is. I assume they blocked it off in there. Again, that's a little bit misleading because it's just from the AI generated similar questions, so they haven't made it really clear that the block of land then obviously ends in a straight line between the ends of those 2 fence lines. The land sold at $155,500 per hectare. Wow, I don't even think that we'd expect everyone to know what a hectare is. But a hectare, 10,000 square meters. So we're going to find the area again. The area is a half by 85 by 120 times sine 62. Definitely calculator required for this one. Don't really remember which one this was off. I don't have a calculator on me, so I'm just going to go to the solutions that we have for these. Oh, look, I guess that one right there. And this is approximately 4503.04 square meters. So the cost is 155,500. Now to convert this into hectares, I just take my 4503.04 and divide it by 10,000, because that's what fraction of a hectare I have. And as we said before, a hectare is 10,000 square meters. And so for this one, good price for land these days, $70,022 to the nearest dollar. And if you write a nice little sentence at the end saying that, that would be even better. But we're going to keep going because I don't want these to go too long for you. It's painful enough for you to have to sit through this many. All right, a stream is modelled by the curve 8 minus x squared over 2 between 2 straight roads that meet at right angles along the positive coordinate axes. So this is slightly better. So as a stream, I've got 2 straight roads meeting along the coordinate axes. That's like the x and y axis. And then again, this is an upside down parabola. It's a little bit wider because it's being divided by 2. And then it's moved up 8. So I know it's going to start up here. And it's going to have a shape something like that. You want to go ahead and find the intercepts for this, the x-intercept. Again, you could very well use your calculator to do this, or you can do the maths involved to find that intercept yourself, and it's going to be at 4. And you can do that, just let y equals 0 and substitute it in. Or again, you've got your graphics calculator, so you can just write the 4 in there. Maybe I'll pop it underneath there. And we're trying to find all measurements are in meters. Oh, it didn't actually tell me what to do. Let's assume they want us to find the area, because I think that seems pretty sensible. Well, they're actually talking about an excavated volume in the answers, but whatever it was. Oh, undo that. Don't know how I did that. So this area here, the area is going to be approximately equal to, well, it is going to be equal to the integral from 0 to 4 of 8 minus x squared over 2 dx. And you can push buttons on your calculator using a graphical display calculator, and we are getting 64 over 3. Says 21 1/3, which I think I've done the maths right there, 64 over 3, which is very good. It then said something about it's being excavated to a depth of 5 meters. We don't need to worry about that, but that would be how you could go ahead and finish it. So if we add in that extra bit, which seems to be missing in the question but is in the answers, excavated to a depth of 5 meters. So now I can find my volume. 5 times 64 over 3. And so that's going to be, whatever that is, 320 over 3. They say in the thing 106 2/3, which is the same thing. And now that's cubic meters. And then they've given us a cost is $100 per cubic meter. So So again, that's missing from the question that I've at least copied in here. Maybe it is on a different bit and I haven't copied it correctly. Cost is $100 per cubic metre. So now I could go ahead and say, therefore, the cost of excavation and that's just 100 multiplied by the 320 over 3, which is approximately $10,667. Again, this was to the nearest dollar. Next question, I think you're getting the hang of this now. Cross-country runner travels 4.8 kilometres on a bearing of 65. There's my 65 degrees from north. I'll just call this the start. And this is 4.8 kilometres. And then 6.2 kilometres on a bearing of 142. So to get the 142, just put your north in, measure around 142. This is 6.2 kilometres. 142 degrees there. A support vehicle travels directly from the starting point to the finishing point, a final checkpoint. Let's use the words in the question. And so determine the time taken by the support vehicle. So first we're going to find the distance, and then once you've found the distance, you can just divide it by 35 to get how long it's going to take. I guess I need to find the angle between the 65. In this is my theta that I'm looking for there. The easiest way to do that is if I think for me is if I kept extending that line. Oh no, that's not really going to help us. Why don't I do it this way? The co-interior angles have to add up to 180. So this angle here and this angle here would add up to 180. So I can find this angle, that must be 115 degrees. And so then I've got 115 and 142, which is 257. So that must mean theta is 103 degrees. We can go ahead and use our cosine rule. And we go ahead and we push buttons on this, and it's going to give us values for D. This is one of those ones where it's going to spit out two values, because obviously we could get a positive or negative square root. And so what we can do from there is you can just figure out that you need the positive square root, and according to this, the distance is 8.66 kilometres. The working for this one actually does it into horizontal and vertical components for each, and then figures it out from that. It's much easier to just use our cosine rule there. So therefore the time would be 8.66 divided by the 35 kilometres per hour, which is approximately 0.2474. Just having a little fit there, 0.2474 hours, and it says to the nearest minute, and so if you just multiply that by 60, you're going to get around 15 minutes. We've done a lighthouse one. This is something similar. A lighthouse is 10 kilometres southwest of a boat, so I'm going to have my boat here. North is up there, southwest is going to be off in that direction, 45 degrees from the south. And a lighthouse, so this is going to be my lighthouse. 10 kilometres there. The boat travels on a bearing of 240 degrees, so the boat's actually 270 would be there. 240 is going to be 30 degrees less than that. If I can get it to draw for me again. If that was 45 and that's 13, there's a little 15 degrees in there where these lines meet. Having the big word boat there has made it a little bit ugly to look at. I apologise for that. at 16 kilometres an hour for 45 minutes. So the distance the boat travels equals 16 times 3/4 of an hour. This is another one where it's 12 kilometres. So this line here is 12 kilometres. Calculate the distance of the boat from the lighthouse after the 45 minutes. So they're just looking for this distance here. That's set up beautifully for a cosine rule again, isn't it? My distance squared is going to be 10 squared plus 12 squared minus 2 by 10 by 12 cosine. The angle between them was 15 degrees, and you push buttons and you get your answer according to the mark scheme that AI generated, which we hope is going to be roughly correct here. That's going to be about 3.14 kilometres to 2 decimal places. It's always nice if you sort of mention that you're rejecting the negative answer, or just like D is greater than 0. So you're acknowledging why you're rejecting the possible negative answer. If you use solven at this point here, your calculator will give you 2, and you just figure out, no, I actually only want 1. Lucky last one here, I think. Goat is tethered to a post by a 10-metre rope. The post is 13 metres from point A on a straight fence, and SA makes an angle. Okay, so here's my post S, and the point A, it's a little bit tricky the first time you read this one. So the post is 13 metres from A on a straight fence, and SA makes an angle of 20 degrees with the fence. So let's read it again. A goat is tethered by a 10-metre rope. The post is 13 metres from point A on a straight fence, and SA makes an angle. So if it's 13 metres away, that's going to be 13 metres from a point A on the fence at an angle of 20 degrees. Determine the nearest point on the fence to A that the goat can graze. So if you imagine a 10-metre rope that the goat is on, I'm just going to dot in the rope. That could be 10 metres there. I could also have 10 metres this way. So there's a little range. If the fence wasn't blocking it, that would be making a nice little arc of a circle there. So the goat is here, chained to here. It can get all the way over here. The closest point is that's the point I'm looking for. Determine the nearest point on the fence to A. So that's the nearest point to A, P1. There is another point. This would be the furthest point from A, but I'm actually after P1. How far, and I need to give the answer how far away that is from A. So I'm just looking for that distance in there. Great, this is one where we can again find the answer. I think this was on Miss Parker's video as well. You could go ahead and try and figure out the angle, but you've got enough information. The side 10 is opposite the 20 degrees. That's enough for me to use my cosine rule, as long as I remember that those two have to be on opposite sides. So I'm going to start with 10 squared, and that's going to equal D squared plus 13 squared minus 2 times D times 13 times the cosine of 20 degrees. And if I use the cosine rule there, it's going to spit out an answer for me. And we can go ahead and find that D is 3.29 metres from A. When you solve it on your calculator, it'll give you another value for P, which is going to be much bigger than that. Obviously, that's the one that's further away, and you want to take the one that's closest. Unfortunately, I don't have a little calculator on my iPad here that I'm recording on to help with that, but hopefully that gives you an idea of what you're trying to do. If for whatever reason, I'm going to just bear with me. I'm going to jump on Desmos on my computer and just see if I can confirm that that's what happens when I type in that equation. If I open the graphing calculator, I'm pretty sure if I just put that in as x squared plus what I've got 13, so that's just 26x multiplied by cosine of 20, and I have to tell Desmos I'm working in degrees. Didn't want to solve it for me. Oh, I can do it the other way. I'm going to just type in y equals that. And I should have a parabola somewhere here. And where does it equal 100? And I'm getting, yep, 3.2. Well, let's actually type in y equals 100. I apologise that you can't see any of this. When I type that in, I'm getting indeed 3.26 according to this one instead of 29. Might be a slight error in what I've typed in here or the way they did it in the book, but it's giving you the right idea. The other value would be 21 metres, which of course would be the further away distance, which we would reject. Hopefully that helps. Thanks for